Yeah. This triple bond's non-polar. Right? The nitrogen is pretty electronegative. Nitrogen is 3.0, but both are 3.0, so both are strong. So it's going to be a tie. So this is what we call a triple bond. We have a double bond. In water, we saw single bonds. There. These are some simple Lewis structures. Sometimes the Lewis structures get quite complicated. For simple Lewis structures, we can generate them like this. For complex Lewis structures, there's an easier procedure to use. And so chapter 13 starts off with the procedure for drawing Lewis structures. They call them Lewis diagrams. They call them Lewis structures. Initially, when you read this procedure, it seems much more complex than we just did. In fact, let's redo CO2. We're going to do CO2 using their procedure. So, drawing the Lewis diagram or Lewis structure of CO2. Step 1, count the total number of valence electrons. Adjust for charge on ions. Okay, so the total number of valence. Carbon has how many valence electrons? Oxygen? And we have 2 oxygens, so that's a total of 6. And there's no charge, so we're not missing any electrons, or we don't have any extra electrons. And so this is a total of 16 electrons. So the total number of valence electrons is 16. Step 2, place the least electronegative atom in the center of the molecule. Which one's closer to fluorine? Carbon or oxygen? Oxygen. And therefore, oxygen is more electronegative, carbon's less electronegative. So we put carbon in the center, and then we'll put the oxygens out here. Step 3, draw the tentative diagram. Join atoms by single bonds. So single bond is just one line. Add unshared pairs to complete octets around all atoms except hydrogen. And so what we're going to do is we're just going to add lone pairs like this to complete the octet. And so I'll need 3 lone pairs and 1 bonding pair that makes an octet here. We completed on the peripheral atoms, these what we call the terminal atoms, or in other words, you got to feed the hungriest atoms first. If you got to feed the hungriest atoms first, what's hungrier for electrons, oxygen or carbon? Oxygen. Oxygen is more electronegative. And so that's why we give the electrons to oxygen first. If there are any electrons left over, then we're going to feed those to carbon and everybody's happy, right? But are there any electrons left over? So let's count them. How many electrons have I used up? I've used up 16 electrons. How many electrons do I have? 16. I have no electrons left over. So unfortunately, carbon does not get fed here. So oxygen has an octet. Oxygen has an octet. Does carbon have an octet? No. Sometimes there's not enough electrons to even feed the oxygens. So that's what we're doing in step 4. Calculate the number of valence electrons in the tentative diagram and compare it with actual. If diagram has more, remove. So sometimes when we feed the electrons, we got to remove them. So here, if I gave electrons to carbon, I have now 16, 18, 20 electrons. 20 electrons, I don't have 20 electrons. So I got to remove them. Well, I got to remove them from the least hungry atom, which would be carbon. And so I'll remove them. So that's what this says. We want to feed it to everybody, but there's not enough. All right, so what we're going to do is this. What we're going to do is this. There's one way, it's called a win-win situation. Rather than oxygen holding on to this lone pair, what if the oxygen shares that lone pair with carbon? Okay, then does that screw up oxygen's octet? No, it doesn't, because oxygen still has an octet. But now carbon's getting closer to an octet. And so we don't want to take both lone pairs off this oxygen. We'll spread it out. So we'll take 1 lone pair off each oxygen and make a bonding pair. In other words, we'll form 2 double bonds. And now what we have is we have the final structure here. Everybody has an octet. Do you see that? So check the Lewis diagram. Hydrogen atom must have only one bond or duet. All other atoms should have a total of 4 electron pairs or an octet. And so we got it. Draw the Lewis diagram for ammonia. Let's try that. Why don't you try this one? You put up the rule again, the step. Let me give you a hint about step 2 fails for ammonia. Step 2 fails for ammonia because hydrogen cannot be in the center. Hydrogen can only form one bond. And so the only atom that can go in the center would be nitrogen. So we'll just do a quick progress check here. Nitrogen has how many valence electrons? 5. Hydrogen has 1. So we got 3 hydrogens. Is there any charge? No charge, so we got 8 electrons. So we're going to get something like this. Now, hydrogen's in the first shell, so it only takes 2 electrons to fill the first shell. So hydrogen's happy to fill the first shell. This is called a duet. Nitrogen's not happy, so we'll make it happy by adding a pair here. Is that what you got? This is good, because then nitrogen has an octet. It's a Lewis structure.
Question. Would it matter if the lower hydrogen was at the bottom or the top? You know, has it on the bottom? I just wrote mine on the top.
No, it doesn't matter. You can write it any way you want. Yeah, I can write it on the side. It doesn't matter. Draw the Lewis diagram for the bicarbonate ion, or hydrogen carbonate, HCO3 minus. Why don't you try that one?
here a little